Alrighty. Hey guys, last webinar we discussed integrating Rive animations to Flutter. But did you know you can actually do animations inside Flutter? Today's webinar will give you just that, an overview of the animation system in Flutter. All right, hello everyone, and welcome to our fifth Flutter at Home webinar. Our speaker for today is our very own Joshua de Guzman. He's a Flutter and Dart GDE and software engineer at freelancer.com. And of course, you will see here his talk is about Flutter staggered animation in a nutshell. So, hello, Joshua.
Hey Johnny.
I, I'm sure lots of our attendees are interested in animation inside Flutter. Anyhow, so before we begin, um, I would like to talk about Flutter Philippines community. The Flutter Philippines community is a collaborative community for anyone interested in developing apps and in using Flutter and Dart. We have already have 1,000 members on Meetup and Facebook. If you're not yet a member, please visit flutter.ph for more details. Next slide. Flutter at Home 2020 is an online event by Flutter Philippines, and we are currently in the learning phase. Learning phase is all about learning how to use Flutter and Dart to help you build apps for mobile, desktop, and web. Later on, we will have the prototype and hackathon challenge. However, both challenges are moved to another date to give way to the Flutter Day and Hack 20. Anyways, make sure to check our FB group for any updates. There is still time to register for the learning phase. I think we still have 2 days. Um, and so if you haven't done it yet, go to athome.flutter.ph. If you complete the learning at the intro to Flutter, you'll get some swags. Anyways, of course, we would like to uh, thank you, thank our partners for helping us sharing our announcements for this webinar. For the QA portion, you may post your questions at flutter.ph/ask. You may also vote for a favorite question. Towards the end of the webinar, um, we will select questions for Joshua to answer. Anyways, thank you for listening and enjoy the webinar. We will turn you over to Joshua for his presentation.
Thanks Johnny.
Thanks.
I'll just try to show. Great. Okay. Okay, I guess we can start. Five. Okay. So hey everyone, thank you all for coming. This talk is all about staggered animation concepts applied in Flutter. So hopefully tonight you'll learn something new, especially in the concepts of animations, creating staggered animations in Flutter, and overcoming the fear and boosting up the confidence of actually implementing animations in your Flutter apps. And yeah, I believe Johnny already introduced me. I'm Joshua. I'm a Google developer expert for Flutter and Dart, software engineer at freelancer.com, and a volunteer at Flutter Philippines. So, to give you a bit of the context of what we are going to talk about or discuss, staggered animation is just a set of animations combined to create intuitive, smooth, and beautiful user experiences for users. As you can see here in the demo, it has a different timings in terms of the transitions of the elements. In Flutter, they are called widgets, and this is how we use the staggered animation concepts on our applications. We have two types of staggered animations in Flutter. The first one is sequential, in which As you can see here on your left side, we have three different properties that we're trying to animate. The first one is the size, next one is position, and the last one is color. So as you can see here, each of the animation objects inside a single animation controller are all animated in order without overlapping timings in the timeline provided from 0 to 1, which is the ending. Next type of staggered animation in Flutter is the overlapping animation, in which, as you can see here, there's an overlapping or gap between the timeline from the first animation object to the next animation object, which is the position, and the first one is the size. So they're a bit similar, but the experiences they bring to our users or to our applications is kind of different. So be careful on what type of animations or staggered animations are going to use, because it really brings a bit of different experience. As you can see here on the demo, the left side is using sequential staggered animation, and on the right side it uses overlapping staggered animations. Great. So for those of you who are just new here in Flutter at Home, or just their first time listening to an actual Flutter webinar, Flutter is a toolkit that allows you to build applications with improved developer productivity for multiple platforms using a single code base. With Flutter, you are enabled to build apps at a much faster rate because it supports hot reload. Hot reload, if you don't know it, hot reload supports iterating the changes in real time. For example, you have changed the color of your application text, you have updated the size of the containers or the widgets in your applications, and pretty much with hot reload you could just reflect the changes in real time. Next thing I like about Flutter, in which I believe improves our developer productivity, is the plugin support. So with Flutter, we have thousands of packages available in pub.dev. These packages are created by Google Flutter team and the community that's built around Flutter. And as I mentioned earlier, Flutter is not just for mobile, it's multi-platform. You can build applications for mobile, Android, or iOS, and even web or desktop, which is currently on beta and technical preview respectively. Great. So now that you've learned what staggered animations and Flutter actually is, let's try to see if what are the things that we're going to discuss on regarding how we can actually create one. We'll just have to discuss a short introduction what animations are and why they're actually important. Different types of animations, at least in the based on the research made by Nick Babbage from UX Planet. We'll just discuss what are the different types of animations, widgets, animation system, and tooling you can use in Flutter for you to be able to animate your application. And last but not the least is we'll try to create our very own staggered animations. This talk is not about discussing in detail animation history, different UX principles applied in motion or animation. This talk is not about Rive, Lottie, or Adobe FX. And yeah, literally this talk is not about Nutshell from Ice Age, but instead we'll just try to discuss the concepts or the theory behind creating animations, especially staggered animation concepts, within a short period of time, and we'll go straight right away to the live coding. Great. So what actually animations are? Please observe the images or the screenshots shown in your screen. So left side and the right demo. Animations are used for us to be able to emphasize and infer functionality for our applications to help our users better understand how they can use our applications or how they can actually proceed with a specific flow inside a product. Animations helps us to create intuitive user experiences for our users so they won't get stuck or blind or They won't get stuck on a specific flow in your application if they don't know where to proceed next. Last but not the least, if your team has the capacity to actually polish your application, then you can use animation for you to be able to stand out from the rest, because there are thousands, if not hundreds of thousands of apps out there competing, to be downloaded to the user's devices. So if you use animations for your products to as a polish applications uploaded in the Play Store, then pretty much you'll likely be standing out or ranking in the top apps available in Play Store. Currently, we're not anymore designing static screens, but instead we're using animations in a sense that it helps us to drive the users to go to a specific content or page we want them to go to. So this is a quotation from Zerp Foundation. I suggest reading the article and the research they've made in this blog. Great, so that's animation, and we've learned how important it is to actually add animations for us to help our users create or provide better experiences inside our applications. Let's try to discuss what are the different types of animations, at least according to Nick Babbage, chief editor of UX Planet. He mentioned that in his research and article that there are actually two types of major types of animation. The first one is functional animations, in which this is used by developers, designers, and teams for them to be able to help their users better understand what they are offering in their applications or their product. As you can see here, this is just a loading indicator inside the Gmail app. So if I were the user, I'll just wait for this actual animation to be finished, because I know that this is a system status that shows that I have to wait for this to finish before I could actually interact again with the application. Next type of animation is delightful animations. These delightful animations are used to be able to bring your company's values or culture to your products with the help of animations. This is typically added at the very end of the product development, especially if you just want to polish your applications. And typically, this requires a lot more resources than the typical functional animation, because delightful animations can also be based from the data gathered, for example, from the usage or analytics of your application, because this is a bit more personalized towards the users that is using your application, perhaps. So in this webinar, we'll just focus on creating functional animations, at least on some of the things that we're going to discuss, and not focus on delightful animations, because for delightful animations, I really suggest using Rive or even Lottie for this one, because they require a bit more complex computations or mathematical setup for you to be able to deliver a wondrous experience. We've learned the different types of animations, at least the major ones, in the context of mobile and web development. Let's try to see what are the different types of animations available in Flutter for us to be able to create staggered animations. First type of animation available in Flutter is or are implicitly animated widgets. Implicitly animated widgets are types of animations in Flutter in which you only have to deal with two things. The first one is the duration, meaning the specific timeline, how long a specific animation should animate, and the properties that you want to change during runtime. So in this example, I am changing the height of the specific container, and every time I try changing properties inside this animated container, it transitions and interpolates from the previous value to the new value you assigned during changing this value. So as you can see here, we have the code here. So we have an example here. So animated container, if I tried pressing this one, it changes. As you can see here, this animated container is subscribed to the height value, which is changing on runtime. As I press the button, I, generate a random height. Specifically, they are just the same height and width for this specific container. So if every time I press randomize, it just loads this one and it assigns the height and width using set state. So the key thing here again in implicitly animated widgets is you only have to assign the duration, which again I mentioned earlier how long the animation should take place. Next is we have the height and width, which are the properties. There are a lot more properties you can change, especially in animated container. So for example, we'll try to change the color. So let's say we have color box colors.blue, and we want to change the color of this animated container whenever I press randomize to colors.blue. So color box, I'll just assign that, and I'll just change the assign state to if color box is equal to colors.blue, then I want to change it to color box. Otherwise, if it's not color blue, then I'll just bring it back to colors.blue. I'll try to run it, hot restart, because I have instantiated a new value. Great. So with implicitly animated widgets, you don't have to worry about disposing or managing animation controller, but instead you only just have to worry about the properties that you want to change during runtime. So in this case, I tried changing colors from blue, height and width, and a lot more to it. You can see more on the documentations of implicitly animated widgets on flutter.dev. Next type of animation in Flutter is explicitly animated type widgets. Now, explicitly animated type widgets is a type of animations that you would want to use, especially if you want to control or have at least a fine-grained control on the timing, the duration, and the interpolation, how your animation is actually working. Because as you can see here, this animated container, which is implicitly animated widgets, is already implemented for you. And without the control of the animation system, you'll probably get stuck on what it actually offers right out of the box. But bear in mind, implicitly animated widgets is powerful as well. So not because they are fixed, you can just use them on a real world scenarios. For example, these is just an example of implicitly animated widget, which is using animated containers. As you can see here, I have 3 animated containers. And whenever I try to randomize the height, it automatically transitions and interpolates from the previous value or the old values to the new values generated during runtime. But again, you may want to use explicitly animated type of widget if you want a fine-grained control on how your animation actually works. So for example, we have this animation controller, and the example is great. So in this example, I tried creating an animation controller. This one. Oh, it's not. Okay. So this one is the animation controller, and I tried creating animation object. Later on, we'll try to discuss the difference between these APIs that we are using here. But for the meantime, let's just try to see what happens if I try on uncommenting this one. So uncomment this one. As you can see here, animation controller has a lot more flexibility and control on how your animation actually is moving. So for example, if I try placing this one, right now it just went to 0. If I tried on changing or adding this one, now again, we're still in explicitly animated type widget, which is the type of widget you'll need for you to be able to create staggered animations. So as you can see here, I'm just changing the square from circle because I'll be using a radius, and try running it. and we should be able to see that this animation is repeating. So as you can see here, uh, we have the duration. Let's just set it to 1 second so we could see the changes in real time. Animation controller, play the animation, and as you can see here, the animation is breathing, but I guess it's very small. So let's just try to change it to 100 or 200. Again, control animation controller, press play. So this is the breathing animation. So as you can see here, it's a bit fast. So as you can see here, with animation controller or with explicitly animated widgets, we can control or we can subscribe whether the animation is actually finished rendering or if the animation is already dismissed. As you can see here, we have a callback, add status listener, which we explicitly add for us to be able to either increase the size of the circle or reduce the size of the circle. So that happens during runtime. We don't have to hard code button for us to be able to run that specific animation. Great, so that's for explicitly animated widgets. You've learned that explicitly animated widgets uses animation controller, animation, and twin, which we'll be discussing in the next section. Last but not the least is the drawing and complex based animations. Now, complex and drawing based animations are pretty much uh, at least requires a lot of computations for you to be able to simulate the physics, the body joints, and those different movements that an animation requires, especially if it's a complex one. So with this one, I suggest just using Rive, or you could just visit them on Rive.app, or you could just simply watch the previous webinar of Flutter at Home presented by Walid, where he shared about how you can use and export Rive app animations in your Flutter apps. Great. So that's all that we have to know for us to be able to create staggered animations. But what exactly the APIs are we going to use? So again, I've mentioned already that staggered animations is controlled by a single animation controller. Staggered animations contains multiple animation objects. And last but not the least, each property that we want to animate is driven by an interpolation or a twin class. Just a high-level overview of the Flutter animation system. Animation class is responsible for holding the values and referencing the ending and the beginning values and the change in values during runtime. And it's also the thing that you use for you to be able to reference the animation status. As we see earlier, we have this callback. We have this callback for the animation status, whether it's dismissed or it's completed. Next thing we have to consider using is animation controller. Again, it's surprisingly used for controlling animation objects and managing animation objects. Next is the twin. As mentioned earlier, the twin is responsible for interpolating the values from 0 to 1, and these are generic type values. These can be int, double, colors, and any values you can think of that can be used to animate an object in Flutter. This is just a pseudocode how twin actually works, or instantiated. This is just a twin between an ending and a beginning value. First one is the height of an object is 50, and if we try to use explicitly animated widgets with the help of animation controller, we could just simply translate this specific object to 100 smoothly. The change from the height of the objects will be interpolated during runtime for you. Great, so the next thing you may want to consider doing is, or using, is the curves, which we'll not try to deep dive, but we'll probably use them. So curves, as we all know from other programming languages like JavaScript or Java, we have curves as a representation for the rate of change of animation over a period of time. So as you may all know, we have easing, we have bouncing animation, we have accelerate and decelerate animations, and a lot more to it. Curves gives you a bit more personality and expression on how you create your animations in Flutter. Based on the animation system that we discussed, we will be primarily using the first three: animation, twin, and the animation controller. For the widgets, we'll just try to use transform and stack for simplicity. Great. So we'll try to Great. So we'll try to go and visit one of the example here in explicitly animated widget, and let's try to see if we could actually play this. I'll just try to reset this one. Great. So let's try to play the basic animation widget. So as you can see here, maybe you've already seen in the slides that this is an actual sequential based staggered animation. And if I try to repeat it, change color, go up, go down, change size. So animations are happening in order. If animations are happening in order, then this is pretty much sequential based staggered animations. So as we can see here in the code, let's try to deep dive basic staggered animation. And we have three properties as mentioned earlier on the size, the position, and the color in which we're trying to animate. In this specific case, and how you use them is to just declare an animation controller, which again surprisingly is used to control animation objects. We have animation class in which it accepts a generic T class, for example in our use case double. And again, animation is used for holding the values that is changing during runtime, and you can use these animation objects for you to be able to reference whether this animation is already completed or dismissed. We have T properties, then we should have three animation objects, right? So animation size, because size is a double. Size of this object is a double. We have to create animation which is a double. Animated position, again, position 0, 0, 0, that's top left. Then probably we'll need a double again. Last but not least is we want to change the color of the circle at the very end. Then we just have to declare animation color for this one. So if we want to try on adding some properties, let's just say we want to create or update the radius of this animation during runtime. So let's say animation, and again, you guess it, radius is based on double, so we'll just use double. Double, I'm having hard time to naming this variable, but I'll just name it animation radius. And if I try to instantiate it, I'll just call in animation radius, which is a very hard variable name to create. And the next parameter that we have to pass on these animation objects is the twin. Again, twin classes are used for you to be able to interpolate from beginning and ending values of your animation. So twin, generic type double, otherwise it will have some compile time error because Dart is type safe. And for example, the first radius that we want for animation is probably say 0. So probably it will look like a square, and after a while we'll just want to change the value from 200. That animate, pretty much you could just simply pass on the controller here, but if you want to control the timings and the curves on how these animations are run inside the animation controller, just simply pass on curve animation class inside this animate callback. And in here, as you can see here, 0 and 0.25, it's already mentioned in our slides that these in the timeline we only have 0 to 1. And personally, I'm thinking, if I'm just computing this one in my mind, I think of it as percentage. So for example, I added here 25, then presumably this animation will end at the 25th percentile of the animation, because this is considered as 100% and this is considered as 0%. At least that's just based from my preference, so I don't have a hard time computing or subtracting 0.33, 0.54, whatever. Just have to assign a specific, at least, percentage in your mind for you to be able to estimate the effect of the animation. So this one is animation radius, and try to run it. Right now, as you can see here, the radius is not changing because we only instantiated it, but we haven't really used it. So to use the animation values, which is, we use to reference the runtime values of these animation, we can use the animated builder, in which it also helps us optimize the way we transition animations inside our Flutter apps. So inside this animated builder, we have a container object, and as you can see here, we have the decoration, which is the radius. And the radius is basically based on the animation size currently, which is supposed to be divided by 2 for us to be able to make it as a perfect circle. Right now, we'll just change it to animated radius value. Just try to run it. Press repeat. And it's not interpolating. Great. So, again, the things that we did for us to be able to create explicit animated widgets is we created animation controller, instantiated an animation controller. Next is we want to identify what animation is, the type of animation we actually want to add inside our app. So in this case, I want to add the animated radius, which in turn I have to instantiate using a twin interpolation class. And in this one, I've specified the interval from 0 to 0.25 of the overall duration. The overall duration I'm mentioning here is 5 seconds. So that's 5, that's equal to 100%. And if it's 25%, then you guess it, 5 divided by 4, you get the time there, 1 point something, 1.25. And last but not the least is we utilize the value inside the animation object or animation builder that we have. Great. That's pretty much it for the know-how on how you can create explicitly animated widgets. Let's try to see where can we take these skills now that we learned from these basic animation widget. So as you can see here, we don't really have to think about a lot of math here. So if you have some fear on, creating animations because they have, a bit of complications in terms of the implementation, then I suggest actually just trying out and experimenting what is the actually best effect you can have for your application. So in this one, we'll just try to use again, as I always do, we'll just reset it so it won't be a problem. Okay, the next thing we have to consider seeing is where can I actually take staggered lists or staggered animation. So in this example, I created a simple staggered list without actually using list view, but instead using a list of objects inside a stack container. So you can see here, with staggered animation concepts, we can delay each objects that are animating before they are be completely shown or displayed inside our screen. So as you can see here earlier, we have an example. Here. Some of the elements presented in these screens are somehow delayed. Others have the different ease in and probably ease out. And that's how you can actually use staggered animation concepts in your apps. So for this one, we'll just go and try to understand how simple staggered list is implemented for us to be able to truly appreciate how awesome the Flutter animation system is. So in this example, we have 3 animations. As you can say, these animations only changes their position horizontally. So what I did was I tried adding an animation controller, instantiated it inside init state with a duration of 2 seconds. Other than that, I created animation object, which in my case I want to animate the position. So since I want to animate the horizontal position, it requires a double data type. So animation double, again, this will be the reference for the values and the status of the animation, whether they are completed or dismissed. So the first animation object we use is instantiated it from starting from 1000. So this is starting at the very right nose, which is already outside our screen, and ends at 0, which 0 is at the end or at the very leftmost part of our devices. And as you can see here, each of these animation objects has their interval. This ends at 50% of the animation. This starts at 25% of the animation and ends at 75% of the animation. Last but not the least is we have the third item, starting at 50% of the animation and ending at when the animation is already actually ended. So let's try on changing some interpolation values here. If we try on changing, for example, 0 0.5, let's try to see if they actually start the same. Staggered list, try play. That creates a different effect from the previously effect we've seen earlier. But what if they have similar interval? As you can say, they will be having they will be animated the same time, and they will end at the same time as well. So that's how you control, the flow of these animation widgets available inside an animation controller. But typically you won't do something like that, because otherwise you'll just use an implicitly animated widget for that if you're just going to animate the entire list, using a single animation movement. So in here I want to move, or I want to start the animations individually. So I have to specify the timings. Oh, I have to specify the timings properly. 0, 25%, start at 25, 0.75. Great. So what we've learned so far is on how we can control the interval of the animation objects available inside, a single animation controller. So as you can see here, as we have learned earlier, we are using animated builder, and each of the animated objects uses transform, which you pass on some offset value, and this offset value here is the x-axis, in which it tries to change the value of the specific object during runtime from right to left. So again, 50 is just the y axis value of the specific object. If I try changing it, as you can see here, that's just the y value for the offset. Next animation objects is probably, it's a bit more larger, so it's at 175, so it starts exactly at the very, very at the bottom of the first item with a little bit of padding. And yeah, that's pretty much it for controlling staggered animations. You've learned how to use animation controller, animation objects, what data type and what specific explicit type we're going to use for the interpolation. You've learned how to instantiate animation and how you control the interval for this animation. Great. So last but not least is we'll try to, as you've probably known earlier, is that the Launch America was actually postponed due to the weather. It's actually raining here as well with me in my place. And right now we'll just try to simulate of some sort how we can use or animate and make this object fly at least Now, using the Flutter animation system, and we will not be using either Rive or Lottie for this case. Great. So hopefully, no, we actually finish this one without encountering a lot of errors, I guess. So I'll just try to delete some of the unused animation objects here. Okay. As you can see here, if I try on playing this one, it's not working. I actually want to run this one on web. Let's see if Flutter is actually good on becoming multi-platform. So let's just try to see if it actually works well as well in web. We'll try to debug on both iOS and web, but yeah, let's try to see. Okay, let's just wait for it to be rendered, but I guess it's done. Yeah, so that's how fast Flutter is. Great. So as you can see here, this is the iOS app. Single code base. This is very responsive in some sort of responsive, but yeah, this is pretty much works how your iOS app works. Actually, see here. Great. So what we're trying to do here is we want to be able to control the pod to fly on to and deploy the astronauts on the ISS because they haven't been there personally. So let's just try to do it in code instead, no? So let's just try to help them surpass this weather. So the first thing I'm thinking in my mind right now, if I want to move this object vertically, I'm thinking what animation object should I think of? So at the back of my head, from what we've learned earlier, position is requiring an offset, which offset is requiring a double. So probably we'll start with an animation that interpolates between double. Animation controller, animation, double, animation, double. Next thing we want to do is for us to be able to instantiate, no? Able to, oh, wala yung lighting ko. I'll just try to search white background. Let me just turn on my fake lighting. Great, so white background. And yeah, so first thing we want to consider doing is animating the x-axis. Animation space x and instantiate the animation object. Animation space x. Space x, not the SpaceX brand, but SpaceX position in the x. Oh, probably that's space y. Sorry, at back of my head I'm thinking SpaceX, so space y because it's vertically. The change we want is to happen vertically. So animation tween. Want to interpolate between the ending and start value. So I'll just see here what's the starting value. So starting value of this one is actually a negative 100. So let's just try to set it to negative 100. Ending value is, let's say, negative 50, I guess. Animate. We want to control the interval, so we'll just use curve animation, parent controller, curve interval 0 or 0, 1, the curve that we want, curves that ease. No? So that's the first type of animation that we've added in our app. Animation space Y. And as you can guess, have to hot restart for us to be able to, utilize the instantiated values at the very top level declaration. As you can see here, nothing's happening because we haven't utilized the value. So let's try to utilize the actual value on the offset. So again, transform.translate allows us to position the animated or the objects that we want to animate inside our stacks, inside our stacks widget. Pass on some animated and that value. So if we want to verify that this animated value is actually changing, we just want to print on some callback here. Add listener print y axis, that's space x, and just string interpolation, hot restart on web, and try and pray. Actually bumaba siya. Just try to change it to 500. Kulang tayo, kinulang. Great. So, yes, it's here. You can see here, I'll just clear my print, press play. These are the changes in values in real time. You could do that using set state now, but it's not optimized in our case, so because it's a lot of values. So as you can see here, reversed, play, reverse. So that's a bit basic. That's not how the pod actually works. Sometimes it may actually rotate, right? So next thing I'm thinking is, what can we actually use for us to be able to rotate this object of some sorts? So, I guess it can rotate using, again, a double animation space rotate, and I'll just copy paste this one, instantiate an animation object, space rotate, and we want our rotation to end at 0 and probably tilt it at, let's just try a single angle here, and we want to rotate the pod when it's probably at the 75%, because probably it's not rotating at the very first 50% of the animation. So let's just try to change it to 50% and assign this animation space assign the animation space inside. Again, we'll have to create an transform dot rotate the angle. So the angle that we need here is animation rotate that value, child. Great. Just try to see if there's actual change in our code. So that's pretty nice, but it's not looking as realistic as it should be, because if it tries to rotate, at least somehow the rotation should help this pod to actually move from whatever it is pointing. So in this one, it's pointing on the right side, so let's just try to help the pod move, at least some percentage, or at least a little points from left to right. Again, as you guess, again, we'll just have to create animation double animation space x, which is x-axis, and I'll just copy this one. So again, let's just try to see where is the starting value. 25. Okay, it's 25. I'll start with 25, no? 25 and end it with 100. Just try to remove the callbacks, and we don't want to shift our pod to the right side at the very beginning of the animation. So let's just say we want to do it at the same time, so it's overlapping at the same time with the animation as we rotate it one angle to the right. So let's just try to hot restart it again. Again, this is running on web and this is running on iOS. This is a bit cool. We have single code base but multiple platforms. Try to play. Great. Right now it's not animating from left to right because we haven't utilized the value. So again, animation objects holds the values, no, that is referenced to it during the interpolation. So we have to utilize it inside the offset value. Press run. Okay, it should run. Cross fingers. Woo! Actually, have some awesome effects there. Let's just try to repeat it. Okay, that's pretty great. And next thing we want to do is, last thing we have to do is probably change the size. No, probably if this is probably in Kennedy Station and we are in the ISS station, then probably we want the pod to appear a lot more bigger than it should be in the specific timing. So you guess it again. We'll just have to use animation double, animation size, space size or space pod size. Copy this or just create one. Twin, double, and space beginning value. Just check what is the initial size of the pod. So this is 50, 50. And yeah, we'll start off with 50. Probably we want to grow the pod to say 200. Animate. Just copy this one. Oh, it's actually raining right now. Let's finish up before the storm hits us, or we can't, or we will have to scrub the launch again in our code. So animation pod size, we just have to use it again inside. So value. Again, we just instantiated a pod size from 50, and it changes from to 150. So let's just try to run it. Try to create staggered animations, and let's see if this actually has an effect. Oh, the problem we have right now is we started at 0, so this will grow from starting at 0. I want to start this at 25%, no? So this actually has a bit more realistic effect. So play, it should increase its size at 25% of the duration, which 2 seconds is the overall duration. Oh, it's raining. Woo. So it's actually, that's just the basic of staggered animation. Again, staggered animation is just a set of animations combined for you to be able to create meaningful experiences for users or intuitive user experiences for users with the help of a single animation controller. And yeah, that's pretty much it. And if you're interested, I'll be sharing a lot of more resources to it. This is just an example project I did over a weekend last April. This is also an example of implicitly staggered animation, in which, as you can see here, I have used a lot of animation objects for me to be able to change the offset and the timings between these animations. As you can see here, these animations has different timings. As you can see here, there's a different delays in the specific items and this check mark. So try one. So again, what I've shared with you is just the overview of the animation system and how awesome it is. No, how awesome Flutter animation is built for you to be able to use it from scratch. And I suggest learning more on Flutter animation system, because it's actually quite helpful, especially if you're just trying to create simple animations like the ones shown in your screen. But if you're really into complex animations and if your team actually wants to implement complex animations, I suggest using Rive, which Rive, it has this GUI of allowing timeline for allowing you to adjust the animation where you want to, or where or when you want to interpolate an animation in specific or given duration. And nonetheless, there's also a plugin called Flutter Staggered. Hopefully, I got it right. Staggered Animation, in which it simplifies how you can actually instantiate animations in your app. So this is also a package from pub.dev, and It just uses staggered animation under the hood, but I guess there's a sequence. Yeah, this one. Sequence animation in which it's very simple. It uses the dot notation for you to be able to add different notation animation widgets or animation objects by just simply adding dot animatable, and pretty much instead of declaring multiple animation twin objects and many more of like this, you just have to do something like this sequence animation builder. But again, it's best if you could actually know how the basics of the system or the animation system works, because without knowing the fundamentals, we'll be having hard time figuring out what happened or where it we went wrong in terms of the implementations of the animation. Great. So to end this talk, I'll just leave you with definition again of staggered animation. Staggered animation is just a type of animation concept in which it consists of sequential or overlapping animation objects. In Flutter, we control it using a single animation controller, and each of the properties that we want to animate is assigned to a single animation or a twin interpolation class. Resources, they have the official resources of flutter.dev, especially the implicitly animated widgets. And yeah, if you like this talk, feel free to submit the feedback on this specific link or scan the QR code. I really appreciate if you find the time on providing the survey, because it will help us or me to improve how we share knowledge with you guys, and especially for our coming webinars. So yeah, we're excited, and thank you for watching this animation. Great. So I guess that's it. I'll just try to add. I'm sorry, I have forgot to add you, Johnny. And yeah. Oh yeah. So we have a few questions.
Oh, thank you, Joshua. I think the web, the space export is quite interesting. I think it does explain how the staggered animation works. It's pretty good. But I think we will have to call yours space Y because it's all vertical instead of X, space X.
Yeah, we have to change the way we name variables right now.
All right.
Actually raining outside.
Yeah, well,
Yeah.
at least you launched your
Yeah.
space capsule before that. All
Yeah, at
right.
least we have. Right.
Okay. We'll check. So we have a few questions here.
Right.
We'll go through them. I think we only have three. So
Yeah.
the first one would be, how would animations affect the performance of the Flutter app?
Great. So by default animation system in Flutter, if you at least try using the explicitly animated widgets, expect that it should run as fast as no what the device frames per second is. For example, if your device supports 60 frames per second, we have this sticker provider, as you can see here earlier. I forgot to mention, but we shouldn't have. Think we shouldn't be deep diving this anyway. The sticker provider is responsible for do. Okay, thank you. May thank you sa YouTube. Okay, so this sticker provider is responsible for signaling that in the frame callbacks we have to animate a specific object. So what happens here is that uh, it it uses ticker mix in, which is responsible for listening for the frame callback and the think functions of the elapsed animations. And with this specific setup for your animations, it's a bit much not performant than using set state and trying to change the values during set state build time. So for example, if you're just using set state, and pretty much you'll end up having junky screens because you haven't managed really the very low level way of calling the frames per second in or the metal GPU of your device, because it's really expensive to have set state objects. That's why we are using animation controller, which again uses sticker provider for us to be able to signal our device that this animation needs uh, helps us to reach a specific number of frames per second for it to be able to run smoothly. So again, animation system in Flutter is probably as fast as what your device can actually offer. So refresh rate 60
Nice.
or 120. And if you're using implicitly animated widgets, I guess it's best if you could just simply use it for small animations. But if you try using this one, for example, the bar chart example, as you can see here, this is implicitly animated widgets. As you can guess, this is a bit okay because we're just using three implicitly animated widgets. But what if these charts actually has a lot more data? For example, 1,000 data. So I guess using the animation system is a bit more performant than just simply using the implicitly animated widget. So yeah, it's there's no sacrifice in making your app a bit more beautiful than no having no animations at all. So performance wise should be good.
Cool, cool, cool. Alrighty, so it depends on your device, and Flutter handles it.
Right.
Cool. With regards to that one, I'll skip this one. Are Flutter animations for web also 60 FPS?
Right. To be honest, I haven't really tried running a profile for this one, but oftentimes, no, 60 frames per second is really a perfect number for smooth animation. Sometimes also
Mhm.
this one is not reaching 60 FPS because there are other elements that are present in your screen. It's not just the animations that you want to show. Probably if you're on the home page, you have other widgets such as the nav bar, you have the up bar. So again, animations is not should not be the root cause why your app is not running at 60 FPS. But for the web, yeah, we just have to wait before it finishes. But again, I'm not sure if it runs on 60 FPS, but for mobile, I'm sure it reaches 60 FPS or 120 FPS if your device supports it.
Okay, cool. All right, next one. Where can I learn more about animation topics like twins and curves?
Right. Uh, if you're not familiar with the Flutter dev, I actually love the documentation on the cookbook. So
Hmm.
this alone actually is a best place to start off with learning the animation twins and curves. And again, they also have these code labs. So if you're into code labs as well, I suggest you spending time and investing time on this one while we are at home. And yeah, join Flutter at home.
All righty. Okay, go, go. The next one would be, is it possible to check if an animation finished programmatically? For example, the app shows the next screen after the animation is over.
Yeah. We could actually we actually mentioned that a while ago. So as you can see here, I'll just try to
Cool.
reset. So we actually mentioned that a while ago. We use animation objects for us to be able to hold the value and the reference, whether the
Mm,
animation object is finish or dismiss. So this one, we have an example here. I don't know where is it. I think in the breathing part. So breathing. Stagnant. Great, this one. So, wow. JDG demo. It's a good thing I have added this one. So this one, we have this
right.
status listener,
Um,
which is
Joshua,
attached. I'm sorry.
sorry. Can you switch the presentation to your screen?
Right.
Sorry about
Right. So
that.
we have
There you
this,
go.
as we mentioned earlier, we have this animated object in
Hmm.
which this is responsible for actually checking whether no the status of this animation is finished or completed or dismissed. So just do the logic. For example, if the animation is finished, probably you want to open another page since you
Hmm.
mentioned that you want to open another page. But in this case, what I'm doing here is, as you've seen earlier, the breathing effect. So whenever it tries to change its size to a much lower dimensions, it tries to reverse the process. So I call in reverse here after completion. Then it goes back to a large size. Then forward again to a smaller size, and again. So that's pretty much how you handle callbacks for the animation, whether it's completed or dismissed. Great.
It's cool. Um, and the last one is there a better way where I can integrate sensory API, lighting, tilting sensors, and controlling animations? I mean, is there a way in Flutter to do that? I guess.
I guess it's pretty much similar on how you would normally handle, other uh, APIs as native, because we have this thing called I think the sensory APIs. Probably we have this thing called platform channels, in which is responsible for uh, passing whatever data is retrieved from the native device, so for example Android or iOS. And with the help of platform channels, we could just simply display the received uh, byte array or JSON data passed around from native to our Flutter and Dart code. So, and but if there's a plugin, just feel free to visit pub.dev. I'm sure there should be a plugin for that sensory APIs. Great.
Right. Okay, I think that's all the questions that we have right
Right.
now. So, cool. Do you have any other um, anything to add or wanted to cover before we wrap up?
Right. So if you guys want to visit the outline of this talk, just visit Joshua de Guzman. I'll just post it here.
Mhm.
Uh, joshuadeguzman.net/talks Flutter Staggered Animation, in which I've added the link to the talk, which will be saved soon, and just the outline of the talk, so for you to be able to review it and revisit what we have discussed in at a much faster rate. This is just a sort of crash course, and these are the resources that I've used. I'll try to share the code base with you guys on how I created this specific example app for this um, talk. And yeah, not last but not the least is, again, submit a feedback if you guys either want or didn't want this talk for us to be able to improve how we share our knowledge with you guys. So yeah, I guess Johnny, I guess this is one of the last webinar for the Flutter
At home,
at Home challenge, right? Hey, Flutter at
yeah.
Home challenge, right? Learning phase.
Learning phase, yes. Yeah,
Right.
this is
So again, for everyone who's interested on joining hackathons, we postpone currently our challenges, prototype and hackathon challenge, to
mhm.
give way to the Hack 20. Please register. We highly encourage you on registering on this event. They are the ones who actually organized the previous hackathon, Hack 19. So probably next Hack 21 again. So please join Hack 20. And don't forget the Flutter Day on June 25. Right.
Yeah. I think those are two exciting events that are coming for Flutter developers everywhere. Yeah, I guess they can also join, of course, the Flutter Philippines group, and if they would like to team up with other, like-minded web developers, sorry, Flutter developers here in the Philippines, they can. Well, I mean, you can do web development now with Flutter.
Yeah, pretty much.
Yeah. So yeah, I mean, you can join and ask around. If we also have a Slack group, right,
Yeah, yeah, yeah.
the group. So guys, just join, and I think it would be a great experience for everyone. All right. I think cool. I think that's all the things that we need to cover, right?
Great. Also,
Or do we?
this T-shirt design was conceptualized by Sir Johnny. Woo!
Yeah. Thank you. I hope you guys like the design.
Yeah, you will get this swag if you submitted or finished the app brewery course. So if you want to
Yep.
wear this T-shirt design made by Sir Johnny, just feel free to finish the course, and we'll ship you the T-shirt. So as soon as the the ECQ and the GCQ policies here in our area was actually kind of probably lifted, I guess.
Lifted or lightened up. Yeah.
Lightened up,
Ah,
yeah. MGCQ.
yeah.
Right. Thanks everyone. Thanks Sir Johnny. Woo.
Thanks, everyone.
and broadcast